In general, I'm an InfoSec engineer at Ocado Technology. I have almost 4 years experience with AWS and some experience with GCP. This year, I have the pleasure of being second year AWS community builder, and in a few days, I'm going to reinforce in Philadelphia as part of the AWS All Builders Welcome Grant. So if you are going to be there as well, don't hesitate, say hi to me. So yeah, it will be nice. That's a little bit about me. So moving on to the topic, I will start with a short introduction to what Zero Trust is, and we'll focus on one of the principles of this model. I mean, least privilege. So we'll talk about policies in AWS. First, maybe let's define Zero Trust in general. So Zero Trust is a way of thinking about security and a set of tools that help protect digital information. And the main idea is we do not rely only on network protections like firewalls or the borders of our network to keep things safe. Instead, we use different methods to make sure that only the right people and devices can access our data, no matter where they are or how they connect. And what Zero Trust really means. In the past, security was mostly network-centric. We tried to protect the perimeter and trusted everything inside. Today, that's no longer enough. The focus has shifted to an identity-centric model, where we verify who is trying to access our resources, regardless of where they are connecting from. Zero Trust combines both approaches, but the priority now is on identity, making sure that only the right users and services get the right level of access. Let's smoothly explore the key principle of Zero Trust together. So the first, never trust anything by default. Always assume potential risk. So next one, grant people only the access they truly need, following the principle of least privilege. It's also essential to continuously verify who is trying to access your systems to ensure security. To further reduce risks, divide your systems into smaller, manageable segments through microsegmentation. And next one, strengthen identity verification by using robust methods like two-factor authentication. Also, keep a close eye on what's happening by monitoring activities in real time. And finally, speed up your response to threats by automating security controls wherever possible. So for today's discussion, we'll focus on the least privilege access. And let's start with IAM, AWS Identity and Access Management. So IAM definition is like it managed who can access which resources and under what conditions. So by applying this approach, we can effectively implement the principle of least privilege and adhere to the core ideas of Zero Trust. Let me see. Okay, sorry. And before we move on the more complex parts of this presentation, an IAM policy is a document that defines who can access, who can perform which actions on which resources and under what conditions. Sorry. And the first important section here is effect. which states whether the action is allowed or denied. Next one, we have principal. Principal shows who, like a user, group, or maybe rule, the policy applies to. Then we have action. Action describes what actions are allowed or denied. And resource, which specify which resources the policy refers to. And the last one, we have condition, which sets any extra requirements that must be met for the policy to apply. And here in this example, we have a principle like example user has access, like effect allow, to all resources in example bucket. But the most important requirements also is here, like he needs to use this range of IP address in condition. So let's look at how access control work in AWS environment, focusing on two main goals, categories like restrict access and grant fine-grained access. So the first one in restrict access is service control policies. So SCP are applied at the AWS organization level, and it helps limit what actions IAM rule and accounts within the organization can perform. The next one is permission boundary, which are attached to directly to IAM rules, and it restricts what those roles are allowed to do, acting as a boundary for permissions, like permission boundary, you know. And then the last one in this category is resource control policies, which also attach at the AWS organization level and help restrict access to specific resources. So these policies help us set broad limits and guardrails on what users and rules can do across AWS environments. And also here, I'd like to mention that RCPs we can attach directly to individual accounts, organization units, and organization root. And in the second category, grant fine-grained access, we have identity-based policies. I know you know what does it mean, but yeah, to sum up this policy, identity-based policy are attached to IAM rules or users, and define exactly what those identities can access and what actions they can perform. And the next one, resource-based policies, are attached directly to resources like S3 bucket, Lambda function, and others. They specify who or what can access the resources. So together, these policies let you precisely control access, balancing security with the flexibility our teams can need. Okay, so we'll go through a few examples of these policies and one extra example. Okay, so maybe imagine you are a user or a role in AWS with a specific set of permissions attached directly to you. So this identity-based policy says you are allowed to get object from the bucket name bucket1. So whenever you try to access any file inside that bucket, AWS checks your attached policies and sees that you have permission to perform get object on all objects in that bucket. If yes, access is granted. This means the permissions travel with your identity wherever you go in AWS. Now, we are looking at the bucket itself. And the bucket has its own policy attached to it. So the resource-based policy says anyone can get object from the public folder inside this bucket1 but only if they belong to a specific AWS organization. So instead of focusing on who the user is, the bucket controls access based on the requester's organization membership. So the bucket itself decides who can access its contents regardless of the user's own permissions. So by comparing these two, a resource-based policy are attached to the resource itself and control who can access it, while identity-based policy are attached to users or rules and define what those identities can do. Next one, SCP. So now, let's imagine our organization wants to enforce a strict rule across all AWS accounts in organization. So no resources should be created or accessed outside the EU Central 1 region. And this SCP denies all actions, but only if the requested region is not EU Central 1. So what does it mean in practice? Users and rules in any account under this SCP can perform any action, but only if it targets resource in the EU Central 1. For example, launching an EC2 instance or creating S3 bucket in EU Central 1 is allowed. However, trying to create or access resources in US East 1 or any other region will be denied by this SCP. And now, let's imagine we have a specific S3 bucket called bucket 1, and you want to prevent anyone from uploading objects to it, regardless of their identity or permissions. So this resource control policy, RCP, explicitly denies the put object action on all objects in bucket 1, because we have bucket 1 / wildcard in resource. So with this policy attached to the bucket, users can still read object, get object blah, 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 or list the bucket contents, but any attempts to upload or override object will be denied. So for example, a user trying to upload a new file to bucket 1 will be blocked even if their identity-based policies normally allow it. To compare these two, so SCP security control policy sets permission guardrails on identities within AWS organization, and it limits what IAM users and rules in member accounts can do by defining the maximum permissions available to them. And this type of policy don't grant permissions themselves, they only restrict permissions that identities can have and apply only to principals inside organization. RCP, resource control policy, on the other hand, set guardrails on resources across organization, and it controls who can access your AWS resources, including principal outside your organization. And this type of policy acts as a final permission boundary or resource access, overriding even override permissive resource-based policy attached directly to this to resources. And yeah, here we have permission boundary. So now we want to create a rule or user with broad S3 permissions, but we want to limit the maximum permissions they can ever have. So the permission boundary here allows all S3 actions on all resources, effectively setting ceiling on permissions. This means that when you attach this permission boundary to an identity and any policy granting permissions to that identity cannot exceed these allowed actions and resources. For example, even if a policy tries to allow EC2 actions, those will be denied because the permissions boundary restricts permissions to S3 actions only. And the last one, this is like extra type of policy because I didn't mention about it earlier. So the last one, let's imagine we have temporary credentials such as those from an assumed role or a federated user session, and we want to restrict what actions can be performed during that session. So this session policy allows the action list bucket only on the bucket name bucket 1, and only if the request is made in the EU Central 1 region. So what does it mean? Even if the user's underlying permissions are broader, during this session, they can only list the context of bucket 1, and only when operating in the specified region. So, for example, they cannot list buckets in other regions or perform other S3 actions like uploading or deleting objects during this session. So, to compare these two, permission boundaries limit the maximum permissions an IAM user or role can have at all times, and session policies limit permissions only for the duration of a specific temporary session. So provide a way to restrict permissions dynamically for that session without changing the identity's permanent policies. Okay. You might ask me, maybe or not, but I assume yes. How AWS evaluates permissions when you make an access request? So this slide doesn't show which type of policy is more important. It's not a hierarchy, but how the AWS check it to determine if allow or deny. So every request starts with a default deny. Nothing is allowed unless it's explicitly permitted. First, AWS checks the service control policy. If it doesn't allow the action, access is denied right away. Done. And next is the permissions boundary. If it's attached, it also has to allow the action. Then we have identity-based policy and resource-based policy. So for the same account, either policy can allow access. But for cross-account access, both policies must allow it. And after that, if there's a session policy in the request, it must also allow the action. And finally, we have resource control policy, and it must also allow the action. So about resource control policy, I mentioned earlier, and about this, how it works, but yeah. And if any of these policies deny access, the request is blocked. So only if all required policies allow the action, access is granted. And let's walk through the grant, fine, grant access. And yeah, it is cross-account example. So on the left, we have account A, which contains a Lambda function. This Lambda function needs to access resources in account B. But we want to do this securely and with only the permissions it really needs. So yeah. How it works? First, in account B, we need to define a role called write access. And this role has permissions to access specific resources like an S3 bucket and an EC2 instance. Account A's Lambda assumes the role in account B. When it does, AWS returns temporary security credentials to the Lambda function. With these temporary credentials, the Lambda functions can now access the S3 bucket and EC2 instance in account B, but only with the permissions defined in the write access role. So here we have a simple use case regarding the real slide with cross-account example. But just a heads up, this is a simple example just to show you a little trick. So yeah, moving on. In account A, there's a free Lambda functions, and each of these functions has its own IAM role, like Lambda demo role 1, Lambda demo role 2, and Lambda demo test. I know that the one of them is different, Lambda demo test. Yeah, and each Lambda needs to access an S3 bucket that lives in account B. But since these are separate AWS accounts, we need a secure way to grant that access. So, okay, how we can set it up? So, account B defines a special IAM role called cross-account demo role, and this role has permissions to access the S3 bucket. The trust policy for cross-account demo role allows it to be assumed by the specific Lambda roles from account A. This means only those Lambda functions you see here can get temporary credentials to access the S3 bucket in account B. And when a Lambda function in account A needs to interact with the S3 bucket, it assumes the cross-account demo role in account B. And AWS STS provides temporary credentials, and the Lambda function uses them to securely access the S3 bucket. So account B remains in control of who can access its S3 bucket. And let's take a deeper look at this case. How much time we have? Okay. In account A, we have Lambda demo role 1 policy, Lambda demo role 1. And the most important part here is that policy allows the principal to assume a specific role name cross-account demo role in account B. What means it can temporarily take on the permissions granted to that role for cross-account access. The rest of part is an extra part to permits creating CloudWatch logs group in account A, etc. But it doesn't matter for this example. This is like an extra code which I did earlier for my tests. Okay, so let's walk through different approaches to defining trust policies for this case in account B. So these progressions, which I will show you, shows how to scale trust policies from simple to more flexible and maintainable configuration. And first, we start with a trust policy that includes a single role in the principal section. So this works correctly and allow that one role to assume the target role. Okay, so next, what if we need to allow more than one role? So adding 2 roles in the principal array also works fine. So we can specify multiple roles explicitly. However, when the number of rules grows and we expect to add even more in the future, like 15, 100, etc., constantly editing the trust policy to add each new rule becomes inefficient and hard to maintain, I guess. So to solve this, we may try using a wildcard in the principal to match a pattern such as all rules starting with a Lambda demo rule. But unfortunately, this approach results in an error because AWS doesn't accept wildcards directly in the principal field. Finally, the solution is to keep the principal more general for example, by allowing all rules from the account and then use a condition element with a pattern match to the role ARN. So this way we can securely allow any role matching the pattern without editing the trust policy every time a new role is added. But it's important to note that if a role's name doesn't match the pattern lambda demo role, it will not be allowed by this condition. So this method works well only if all relevant roles follow the naming convention. Like here we can see lambda demo test and access denied. So, okay, you might wonder why I've assigned identical roles with the same permissions to each lambda function in this example. So let me clarify. This is a simplified demonstration to highlight two key concepts. So first, it explains how wildcards can be used carefully in IAM policies, but they should always be limited as much as possible. So second one, it shows how conditions in policies help follow the rule of least privilege. For example, even if permissions look very open, conditions like AWS, I don't know, maybe source IRN or principal tag, etc., can limit access so that only certain resources or situations are allowed. So in real life, each Lambda function should have a role made just for its needs. Sorry. Yeah. Okay. So we've seen some example how policies work, and hopefully you are now starting to get a sense of how powerful but also how complex IAM can be. However, it's easy to make mistakes, and sometimes those mistakes can have serious consequences. So this is why it's crucial to avoid common pitfalls like accidentally exposing your AWS keys. I know that is still common. I know you know. Okay, so now let's move on to some IAM best practices that can help you keep your AWS environment more secure. So yeah, here I put only a few most important IAM best practices. I know we have more, but yeah, maybe the first one is to enhance security in AWS. So I recommend, and AWS also recommends, to start by using IAM rules with temporary credentials for our applications, etc. So yeah, it's also essential to require MFA for all users, including the root accounts, and to also avoid using the root account unless absolutely necessary. So following the principle of least privilege is a key. And here, begin with restrictive permissions and only broaden them when truly needed. In addition, make it a habit to regularly clean up unused users and rules to reduce risk. And you can strengthen your policies further by adding conditions like MFA enforcement or restricting access by API address or region, as we saw in earlier slides. When delegating permissions, apply permissions boundary to limit the scope of what can be granted and manage permissions across accounts effectively using service control policy, SCPs. So SCP is really powerful type of policy, also RCP, etc. And finally, remember to rotate access keys regularly and store them securely to prevent unauthorized access. For example, you can set up automated reminders to change keys every 90 days and use use AWS Secrets Manager to keep keys encrypted and easily manageable. But of course, you need to remember that these are only a few examples, maybe a few general examples. So everything depends on your needs. But yeah, and here are a few key takeaways. So everyone, help yourself. And any questions? So I only suggest that because I see the time, and yeah, I only suggest that if someone has some question, comments, etc., also you can write to Xaba, and if you want, you can reach me out on LinkedIn. Here is my QR code to my account. So yeah, always I try to respond as soon as possible. So yeah, so feel free to reach me out on different way, and yeah, thank you.